Okay, let's talk about points, relations, and functions. So the very first thing is we've been talking about these linear equations in two variables, and this is what we call the standard form of a linear equation in two variables, standard form. I only mention that it's standard form because most of you are familiar with this other form. Do you know this one, y equals mx plus b? Has anyone seen that form before? Do you know what that form is called? It's okay if you don't. We're going to learn it later. It's called slope y-intercept form. But it's just basically, we were talking about last time if you wanted to use a graphing calculator, how you would actually have to have y by itself in order to graph. So these could be, various forms of linear equations in two variables. A solution to an equation in two variables can be written as an ordered pair. So that's going to be like this, x, y, and the order matters. And then an equation in two variables will have an infinite number of solutions. So let's talk about this. This is what we call the Cartesian plane, or otherwise known as a coordinate plane. And we have what's called the y-axis and the x-axis. And we use this for graphing. The x-axis we've been looking at when we've been graphing things on a number line. Basically, the x-axis is the number line. It starts out at 0, so we call this point 0, 0. So we're using, again, the idea of our ordered pair, x and y. The x always comes first, so we're going over, and then the y comes second, then we go up and down. Whenever we have a coordinate system like this, we always want to label our scale. And by the way, you can use a different scale on the x-axis than the y-axis. You might decide to count by 1, but just to put the numbers in, if we go 2, 3, 4, 5, 6, 7, 8, I'm using what's called right here a scale of 1 because I'm counting by 1, even though I only labeled every other line. I only did that because I wanted it to look a little bit, more spacious. It couldn't get really crowded if you put every single number in here. So since we started at 0 in the middle, over here we have -2, -4, -6, -8, and again, I'm using a scale of 1. Now, just because I want to show you a different kind of scale, let's say on the y-axis I wanted to count by 5. That's totally fine as long as we're consistent. So if I wanted each line to be worth 5, this would be 5, 10, 15, 20, 25, 30, 35, 40, and I'm using a scale of 5. If I go down from 0, I have -10, -20, -30, -40. If I want to even label this last line, that's -50. And again, here I'm using a scale of 5 because I'm counting consistently by 5, even though I only labeled every other line. Does that kind of make sense? So as long as you're consistent, that's the most important thing. And the other thing to realize is you're actually naming that line. A lot of people, they think it looks nicer to put the numbers in between the lines, but that's actually not helpful at all because then you're like, well, which line is that number? So you actually want to always put the number right on the line. Okay, another feature of the graph and something you'll see all over is like anytime you see graphs in your everyday life, a lot of times the graphs might start out in this very first quadrant. Because the x and y axis divide the plane into 4 different regions, we call these quadrants. Quadrant, because quad is like 4. So this is quadrant 1, and then we actually go counterclockwise from here. Quadrant 2, quadrant 3, and quadrant 4. Is that how you do Roman numeral 4? Okay, just making sure. You put the 1, I was just talking about that in my last class, Roman numerals. You put the 1 in front of the V because this is Roman numeral for 4. V is 5, and then if you put the 1 in front, it actually subtracts it. Okay, in quadrant 1, what you're going to notice is every single point here, like if I were to plot this point, this is x is 2, y is 10. So this point is 2, 10. And what do you notice that those 2 points have in common? They're both positive. So in the first quadrant, we can say that all of the x values are positive and all of the y values are positive. So anytime you have a point where both x and y are positive, it's going to be existing in this first quadrant. Okay, as we go counterclockwise, if I have this point right here, who can tell me what they think the coordinates of that point is? In other words, what's the ordered pair that would be associated with that point that I just plotted? Yes, negative 8, 20. Notice that she put the negative 8 in front of the 20 because we're always going over and then up or down. Okay, so that's x and y. And all of the points in quadrant 2 are also going to have something in common. Do you know what that might be? Yes, all the x values are negative and all the y values are positive because over this direction, these x values are all negative, and then when you go up, you're going positive in the y direction. Okay, let's go over to quadrant 3, and I'm just going to pick a random point, and someone tell me what is the coordinates of that point that I plotted. Yes, negative 6, negative 20, right? Negative 6, negative 20. And who can tell me something that they notice about all of the points in quadrant 3 then? They're both negative. X is negative and y is negative. And then over here in quadrant 4, I'm going to plot this point. And who can tell me what the coordinates of that point are? 8 is the x, good. Negative 30 is the y. And what do we notice that in quadrant 3, or quadrant 4, I should say, what do the x's all have in common and what do the y's all have in common? The x's are all positive, right? And the y's would all be negative. Now, what if I have a point that's located on the axis? So can anyone tell me what the coordinates of that point are? And that point lies where? It's not in a quadrant, is it? Yes, 0, and it's actually, I drew my 30 really weird, so it's actually 0, 30. All of your points on the y-axis are going to have something in common. Let's do another one. So down here on the y-axis, what's this ordered pair? 0, negative 30, right? What do you think all of the points on the y-axis have in common? They could be, actually the y-coordinate could be positive if it's above the x-axis. It would be negative, the y-coordinate, if it's below. But notice how on the y-axis, all of the x-coordinates are 0, and then the y-coordinate is just another number. So I'm going to use the letter B to represent that other number. So on the x-axis, all of the coordinates start with a 0. Did I say y-axis? Yeah, I hope I said y-axis. And we call these y-intercepts. Okay? Any point that exists on the y-axis is called a y-intercept. So that's why before last time I was saying it's so easy when we were finding ordered pairs. If you plug in x is 0 and you get a y value, every time you have x is 0, you have a y-intercept, a point that exists on the y-axis. We call it an intercept because it's intercepting that axis. Okay, what do you think is true then on the x-axis? So if I plot that point right there, can anyone guess what the ordered pair would be for that point? We could start at the origin, which is 0, 0. We go over to what? Negative 7. And then, do I go up or down? How much do I go up or down? 0. So that's negative 7, 0. Okay, if I slid all the way over to this point, who can tell me what the coordinates of that point would be on the x-axis? Yeah, close. I went right past 8 to 9, 9 comma 0. So any point that is on the x-axis is going to have something in common. What is the x-axis all the points going to have in common? They're all going to have y equal to 0. So on the x-axis, which is called an x-intercept, you could have a number, comma, 0. So you're always going to have y equal to 0, whereas on the x-axis, you always have x equals to 0. And that's what we were talking about before, just the idea of whenever you use 0, you're ending up finding an intercept. Okay? Either an x or a y-intercept, depending on where you're plugging the 0 in. Okay, so some other examples, if we were going to graph and plot these points, now it also says to label the points. When you put the ordered pair next to the point, you've labeled it. So this point right here is 2, 5. To get to 2, 5, I would start at the origin. My x is 2, so I go over to 2. My y is 5. I slide up to 5. This point right here is 2, 5. Since the x and y were both positive, notice where it lands. What quadrant is it in? Yeah, it's in quadrant 1. Okay, here I have negative 3, 3. So I'm going to start at my origin, where it all begins at 0, 0. That's why it's called the origin. We slide over to negative 3, and we're going to go up to positive 3. So I have negative 3, positive 3. I plot my point. I label it negative 3, 3. And notice that this point ended up in quadrant 2 because the x was negative and the y was positive. Then we have right here 0, negative 4. How do I get to 0, negative 4? Well, I start at 0, 0. It says to go over 0, so I'm not going anywhere. I'm just sliding down to negative 4. This point right here is 0, negative 4. And since it's on the y-axis, what do we call it? A y-intercept. Okay, another name for the point 0, 0 is the origin. And that's going to be this point right here, 0, 0. It's where the x and the y cross. So 0, 0 is technically an x-intercept and a y-intercept. It's actually where x and y intercept each other, isn't it? Okay? So here's some more examples looking at the graph. Now, can we take the points and can we come up with what the ordered pair is? So, who can tell me what they think the ordered pair for A would be? Negative 8 up 2. Great. What about B? Good. 0, 6. Excellent. What about C? And I'm putting parentheses around these points. Point D, 4, negative 6. And E, negative 4, 8. Great. And what about F? (6, 4). Okay, any questions about that?